From MRIs to EKGs, sonograms to scanners, medical technology allows doctors to monitor vital information about the inner workings of the human body. Imagine if some of these machines could be made so thin, light, and portable that they could be attached right to the surface of your skin and go wherever you go.
There's some very sophisticated device functionality sitting on my skin now.
2 NSF-funded innovators have done just that by engineering something called an electronic tattoo, a microelectronic health monitor that has the potential to revolutionize the field of healthcare technology.
The electronic has always been rigid. To make electronics flexible, that's quite a challenge.
The path taken by John Rogers and Hyun-Gong Hwang to develop the electronic tattoo is an example of how collaboration is often a key or critical part of the innovation process. It all started in 2005 when both men worked at the University of Illinois at Urbana-Champaign, and Hwang happened to stop by a lecture Rogers was giving on campus.
Then we started talking, and we find John's work very fascinating, and John found my work on mechanics useful. So naturally, the two of us evolve and work together.
At the time of their first encounter, Rogers, a material scientist and electrical engineer, was looking for new ways to use electronic circuits formed on the surface of silicon. Silicon is a natural semiconductor that has electrical properties between that of a conductor, a material in which an electrical charge can flow freely, and an insulator, a material that doesn't conduct an electrical charge at all. Semiconductors are the heart of most electronics today.
So at a very simple level, you can use a semiconductor like silicon as a switching element to turn electricity off or on.
Hwang, a mechanical engineer who has since moved to Northwestern University, specializes in the mechanics of curvilinear materials, which have surfaces that are wavy.
Curvilinear surface means it's a surface that's not flat. That's not, for example, my hat. The surface is curvilinear.
By combining their fields of expertise to hatch the initial idea of the tattoo, they set out to manufacture a prototype, something that has taken about 7 years and multiple breakthroughs to produce.
But one of the key things is to make electronics as flexible as possible that can follow the skin morphology.
The first breakthrough happened when they figured out how to slice off the surface layer of a silicon wafer. This new technique resulted in silicon that could bend, just like this single sheet of paper. Next, they discovered how to make silicon elastic, allowing it to be either flat or wavy in shape.
Suddenly you have a form of silicon that can bend, it can stretch, it can deform, it can coat and conform to curvilinear shapes, very much like biological tissues.
Even though it is called a tattoo, there is no need to pierce or puncture the skin. Instead, the device sticks on.
So what we can do then is we can take this device, laminate it on the skin, almost like a children's temporary transfer tattoo.
To figure out how to engineer this, Rogers and Hwang looked to nature, noting how easily lizards stick to walls.
Like gecko and others, they can easily attach to a wall and easily let go. So for us, we want to borrow some of that idea and to make the electronic not using glue to have strong adhesion with the skin.
Once attached, it can wirelessly detect electrical signals from inside the body, such as those given off by cells within the heart that cause it to contract and pump blood through its 4 chambers.
This particular device is powered inductively. So there's a coil here. I can bring a wireless power supply in proximity to this device and deliver power to it through the air.
Rogers and Hwang filed at least 10 different patent applications with the U.S. Patent and Trademark Office to protect their invention before commercializing it. Patents allow inventors to acquire what are known as intellectual property rights to their inventions for limited periods of time.
The intellectual property is absolutely crucial. If that's not done carefully and thoughtfully, and if you don't really have distinctively new ideas that are well separated from things that people have tried in the past, it won't be viable. You won't be able to commercialize it.
A startup company called MC10 has licensed the multiple patents and patent applications and is developing a new generation of flexible healthcare devices.
While doing mechanics work, I never thought that I would have so much interaction with electrical engineers or material scientists. But now it's really at the interface we create new devices that never existed before.
Innovation brought to life by a unique and long-lasting collaboration that has the potential to stretch the limits of modern healthcare technology.